Hey everybody, just wanted to spend a little bit of time going over what is going to be on exam 1 this Friday. It's going to have all kinetics, and it is also going to have just a little bit of the introductory stuff to equilibrium. So let's spend some time and get you ready for this test. Okay, there's going to be a total of 9 multiple choice questions. Okay, the first 6 are going to deal with kinetics, and then question 7 is going to be manipulating the equilibrium constant. Excuse me. And questions 8 and 9 are going to be you writing the equilibrium expression. Okay, or finding which one is the correct equilibrium expression. Okay, so also something that's not written is that questions 1 through 4 all relate to a specific mechanism. And so we want to make sure that you know what the terminology used in a mechanism is, transition states and intermediates, products, reactants, and that reactions, the steps in a mechanism must add up to the total mechanism and that sort of stuff. And so that's question 1, and then 2 and 6 deal with the multiple choice, deal with kind of that sort of idea, those ideas. Question 3 is something we didn't cover in class, but we definitely addressed it in the video lectures. Keep in mind that there are certain requirements that a mechanism must follow. One of them is that the steps must add up to the overall reaction, like we said previously. But the other one is that the slow step must reflect the rate law, right? The stoichiometry of the slowest step must reflect the rate law. So definitely go and look up that. And I will say that if I was going to look it up, I would go to the Schoology videos, and then I would go into unit lecture 2 as soon as this loads. Okay, and then so lecture 2 here, and then I would go back and look at some of the mechanism questions. Okay, and so definitely the mechanism in here has that concept. Okay, so now coming back to multiple choice here, let's see, I have to move me to go to here. Now put me back. Okay, there, go back that way. Okay, so and then question 4 is theories of reactivity, and have to do with how molecules react. Do you remember collision theory and what the parts of collision theory are? Yeah. Okay, so question 5, I promised that I was going to have a multiple choice question that deals with finding the units of the rate constant. So that's good. Question 7 is manipulating the equilibrium constant. So remember, when you reverse a reaction, so that the reactants then become the products and the products then become the reactants, just keep in mind that becomes the reciprocal. And then when you multiply a reaction by a coefficient, okay, the coefficient then becomes the power that you raise the equilibrium constant to. So my guess is you're going to have to deal with that. And then questions 8 and 9 have to do with writing equilibrium constants. Just a couple of notes I put here. Remember, it's always products over reactants. It's always, always, always products over the reactants. It's never anything else. And always remember that you only use the gas and the aqueous species. Okay, anything that's gas, anything that's aqueous. You do not use solids and liquids in an equilibrium constant. Okay, now I did do something a little bit different with the formatting, which I'll get to in a minute, but there's only 2 open-ended questions, And the first open-ended question has to do with the integrated rate law and some of the graphing things that we talked about. Okay, and so I would definitely keep in mind that the graph of concentration versus time is different than those second and first order integrated rate law questions. Okay, so if I'm going back to here, okay, these integrated rate law questions where you have to plot some things and do some math and things like that, okay, when you're plotting 1 over concentration versus time, that's one thing. And then very quickly and awesomely here, if I can get this open, okay, remember that we talked about graphing an average and instantaneous rate. Okay, those are two totally different concepts, but I'm pretty sure that I'm going to want you to kind of know the graphing and what that means. Not only that, but the slope of this graph here, when you go into these videos, means something different. Okay, it means here we're determining the rate, okay, as opposed to when we go into here and we have the integrated rate law. Remember, the slope is the rate constant. Okay, so I think that those concepts are very important to keep in mind. Here, let me move this so I can get to my presentation button. Okay, and so I think that I want you to know the difference, how and when to apply those things, and I think that that sort of stuff relates to concepts that you're applying in lab. The second question is going to be a methods of initial rates question. I'm going to give you information, experiments, concentrations, and initial rates, and you're going to have to figure out what the rate law is, what the rate constant is, and what the units are of that rate constant. Now, the thing that I did that I thought would help out people more than anything was I eliminated a couple open-ended questions, because the open-ended questions have a tendency to go have multiple parts, A, B, C, D. So not that I got rid of them by any stretch of the imagination, but I cut them out and I replaced a couple of those open-ended questions with some short answer questions that are only just one part. Okay, the open-ended questions that I have are multiple parts, where you're going to have part A, B, C, D, and you have to answer them, and they're kind of related to each other. Okay, but the short answer questions are just one concept and maybe one math problem, and you go from there. Okay, and so those 5 short answer questions, there's a related rates question. So you're thinking about related rates. Remember, you give a reaction with coefficients, like what is, if this rate is half of this because it's a 2-to-1 ratio. We did some sample problems like that in class, and then in the video that's good too. And then there's another method of initial rates. This is very similar to the long answer question, or the open-ended question that we had, or that we talked about in the open-ended question number 2. Yeah, that's it. And then questions 3 and 4 is just applying the first and second integrated rate law, first and second order integrated rate law. I think it's important for you to tell the difference between which rate law is which. So you'll have both equations, but I'm not going to tell you which one is the first order rate law and which one is the second order rate law. Just know that the first order rate law is the one that's ln of blah, 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 and the second order is 1 over the concentration, blah, 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 blah. Okay, and so I'm going to have you do some math with that. And then lastly, the last little topic is we're going to convert between KC and KP. I'm either going to give you a KC or a KP, and you're going to have to apply that formula. Okay, so we have just a couple of questions on equilibrium, but mainly this first test is all going to be kinetics. So feel free to get in contact with me if you have any questions. There's a whole bunch of different ways you can do that. But good luck, and we got this, okay? You guys can do this, and I know you're going to be successful because you guys are awesome.